So let's just jump right in. We all think we know what light is, right? It's the stuff that lets us see. But the real story of what light is, well, it's not some dry physics lesson. It is a full-blown, centuries-long battle of ideas fought by some of the most brilliant minds to ever live.
And you know what? That's not an exaggeration. This is a story about absolute geniuses being completely 100% certain they were right, only for the universe to turn around and prove them spectacularly wrong. It really is a thriller where the big mystery is the nature of reality itself.
So where does this whole thing begin? Well, we have to go back to the late 1600s, to the undisputed champion of science, Sir Isaac Newton. I mean, when Newton talked, everybody listened. And Newton, he had a very, very strong opinion about light. See, to Newton, the entire universe was like a giant clock, a predictable, understandable machine. So, of course, light had to be a physical thing. He called them corpuscles, which is basically a fancy word for tiny invisible pellets, like little bullets of light just streaming through space. And this sets up the central conflict. On one side, you've got Newton, arguing that light acts like a ball you throw. It goes in a straight line, it casts a sharp shadow. But on the other side, his rival, Christian Huygens, said, no, light acts like a wave in a pond. It should bend, it should ripple. But Newton's logic seemed impossible to argue with. I mean, if light was a wave, shouldn't we be able to see around corners? So here's the kicker. Newton's fame, his sheer reputation, basically settled the debate. For more than 100 years, science just accepted it as fact. Light is a particle. Case closed. Or so they thought. But science, it rarely stays settled for long. After a century of everyone being so sure, one man and one simple experiment were about to just blow Newton's entire theory wide open. So for over a century, the particle theory just dominated everything. Then, in 1801, a physician named Thomas Young walks onto the scene with a truly game-changing experiment. And just a few decades after that, the math of a guy named James Clerk Maxwell would seem to confirm, once and for all, a completely different answer. Young came up with this devastatingly simple idea. Just think about it for a second. If light really is just a stream of tiny bullets, like Newton said, and you fire them through two little openings, what should you see on the wall behind them? Right? You'd expect to see two clean, bright lines. Two perfect little bullet holes where the particles shot through. It's just common sense. But that is not what Thomas Young saw. What he saw was something that, according to everything Newton had taught the world, simply should not exist. He saw this, a weird barcode, a whole pattern of light and dark bands spread out across the wall. How on earth could particles just passing through two slits create patches of total darkness? It made absolutely no sense. The only possible explanation is something called interference. This pattern is the absolute smoking gun for waves. Just like ripples in a pond, the light waves passing through those two slits were spreading out and crashing into each other. Where two wave peaks met, you got a bright spot. But where a peak met a valley, they canceled each other out. They created darkness. Newton had to be wrong. Light was a wave. So, for almost 100 years after that, the wave theory was king. But just when scientists thought, okay, we finally got it figured out, the universe decided to throw them another massive curveball. The particle was about to make a shocking comeback. So here's the problem. The math had a giant, gaping flaw in it, nicknamed the ultraviolet catastrophe. Basically, the wave theory predicted that any hot object, like, say, a glowing piece of metal, should be blasting out an infinite amount of high-energy UV radiation. We know that doesn't happen. If it did, your kitchen oven would literally be a death ray. The perfect wave theory was completely fundamentally broken. To try and fix this, a physicist named Max Planck came up with a really radical suggestion. He said, maybe energy isn't this smooth, continuous wave. What if it comes in tiny, discrete little packets, fixed chunks that he called quanta? It was this desperate, bizarre idea, but it actually worked. And then Albert Einstein took Planck's idea and just ran with it. He looked at something called the photoelectric effect. See, if light were a wave, even a very dim red light should, eventually, build up enough energy to kick an electron loose from a metal plate. But it never does. A bright blue light, though, does it instantly.
Einstein realized light wasn't arriving like a gentle wave. It was hitting the metal like a hail of bullets. A single blue bullet, a photon, had enough punch, while billions of red ones just didn't.
And just like that, the particle was back in the game. It was total chaos in the physics world. Young's experiment proved, beyond a doubt, that light was a wave. But Einstein's work proved just as clearly that it was a particle. How could it possibly be both at the same time? So what do you do? What do you do when you have two completely correct facts that totally contradict each other? Well, you don't pick a side. You have to accept a much deeper and much, much stranger truth. And the answer, the real breakthrough, came from a physicist named Louis de Broglie. He suggested this radical shift in how we even think about it. He said, stop trying to ask what light is. Stop trying to stick a label on it. Instead, just focus on how it behaves in different situations. And this brings us to the absolutely mind-bending conclusion: wave-particle duality. The idea is that light actually travels through space like a wave of pure potential, of possibilities. But the second you try to look at it, the moment you try to measure it or make it interact with something, it collapses and acts like a single particle in one definite spot. It isn't one or the other. It's both, depending entirely on how you look at it. Now, I know this might sound like some totally abstract, philosophical debate, but this 300-year duel for the soul of light has completely, fundamentally shaped the world that you and I live in today. I mean, really think about it. The internet streaming to you right now through fiber optic cables, the laser that reads a Blu-ray disc, the digital sensor inside your phone's camera. Every single one of these technologies was built on our understanding of light's bizarre, two-faced personality. So, in the end, we just stopped trying to force light into one box or the other. We accepted the strange paradox. And by learning to harness both its wave nature and its particle nature, we unlocked the secrets to building our entire modern digital world. And that really leaves us with a fascinating final thought. This whole journey taught us that the very act of observing something can fundamentally change what it is. It really makes you wonder, what else out there in the universe, or even in our own lives, behaves differently just because we're looking at it?